All right, I think we actually have to do a reduction order because you guys have been doing a very good job of distracting me. So I'm going to start with an easy one, which is I have x squared y double prime plus xy prime minus y equals 4 over x squared, and someone tells me that one of the homogeneous solutions is x.
Oh, so we're given homogeneous solutions? Okay.
You're going to be
That was
given
what was
one of
confusing
the
me, so I was
homogeneous
like,
solutions.
How are you finding one and not the other? It was really tripping me out.
Yeah, so the x squared, the x, and the minus 1, right, are the coefficients here. If they were a constant, and a constant, I would be able to find two solutions really easy.
Yeah, that was why I was confused.
Right? Because they're variables, right, because they're x's, I don't know whether the trick for guessing at e to the rx, that might not work here.
Yeah.
You guys see that? Okay, so a method you could use to find something like this, right? You could envision teaching a computer how to differentiate basic functions, right? And then you could envision also teaching a computer to add those things together and just check and see if a differential equation is satisfied, right? So one thing you might do is you might have a computer program that searches for solutions and kicks one out when it finds it. Is it guaranteed to find the other solution? Maybe not. Maybe it's not something I taught the computer to differentiate, and so it's not going to guess that ever, right? But if I find one through whatever trickery, then I can use this and reduction of order to make this thing, to solve this thing generally. So what was our procedure for reduction of order? Start with a homogeneous solution. So you got one. Cool.
Times that by mu.
So then we multiply that by an arbitrary function. So that's our stage of guess. Y hat is mu times x in this case. So that's mu of x times x. And then you should take some derivatives, right? So y hat prime is mu
That's mu prime x.
plus mu prime x. And y hat double prime is mu prime plus
mu double prime x
mu double prime x
plus mu prime.
plus mu prime. Cool. And then you take those and
Put them in the original equation.
stuff them into your original equation. So I'm going to call this something. I'm going to call this star, I guess, for lack of creativity. So star evaluated at y hat. Oh, I want to write this someplace else so that you guys can see what happens here. Cool. Okay, so star evaluated at y hat is, or becomes, I guess, x squared times all of that jazz. So that's a mu double prime x plus 2 mu prime.
Yeah.
And then I got a plus x, and that should be times
Mu plus mu prime x.
mu plus mu prime x. And then to that I should add, no,
Subtract
I should subtract
mu
Mu
x.
x.
mu x. And this is all supposed to equal 4 over x squared. Okay, so why am I allowed to assume that it's equal to 4 over x squared? Why don't I have a question of equals?
Because we know that that's a solution.
Close.
We know that it's original equal.
Close.
Because we know it already solves zero.
No. That's the same thing. It's close though. I'm imposing a condition on mu.
We made it that way, right?
You guys see that? Like, this is me forcing mu. You guys cool with that? So, this isn't me checking something. This is me forcing something. So I'm saying, if I'm going to solve my differential equation with y hat, right, which is mu times my original homogeneous solution that they gave me, then mu is going to have to satisfy this differential equation. You guys see that? So all told here, I think I got x squared times x mu double prime plus 2x squared mu prime plus x mu plus mu prime x squared minus mu x is 4 over x squared. And I didn't do a ton of simplifying there because I really wanted to see something. What do you guys see in that?
The mu's are gonna cancel.
Yeah, these guys canceled, right?
Yeah.
What's that about?
Well, like,
Like, why did that happen?
You have all these solutions.
Yeah, because you had one of the homogeneous solutions. That's not a mistake, right? You guys see that? That happened because we had a homogeneous solution. So those guys are going to zero out on me. And then all told here, I think I've got x cubed mu double prime plus 3x squared mu prime is 4 over x squared. And if I had been being really smart, I probably would have underlined things since I took care of them. Right? Okay, so now I'm here. Now what?
multiply by x squared plus x.
X cubed, divide by x cubed.
Yeah, I think maybe multiply by 1 over x cubed would be a good idea. Okay, so if I multiply by 1 over x cubed, I'm at mu double prime plus 3 over x mu prime is 4 over x to the fifth.
Oh, and then we have a
Yeah, you can remember that this is,
Bernoulli's or something.
yeah, you can remember this is Bernoulli, or you can just solve it with variation parameter. So, what's the trick for solving this part?
Oh, this is where we reduce the order.
Yeah, this is the actual reduction of order stuff. So right here, you need to what?
Oh,
Because this guy, right?
Z is mu prime or something.
Yeah, this dude is first order in mu prime. So I'm going to let z be mu prime. You guys see that? That's really me thinking like, hey, that's mu prime prime, and that's a mu prime. There's no regular mu's. Oh, and I'm going to need my y hat later. So remember I guessed this back at the beginning. I guess y hat was mu times x. Oh, and also I guess I should add this. I also let z be mu prime. It's a good idea to write these off in the margin with some kind of other color. So once I guess z is, or once I let z be mu prime, I have z prime plus 3 over xz is 4 over x to the fifth.
And then now it's actually Bernoulli's.
Yeah, now this is actually honest to God Bernoulli. The other one was like Bernoulli and mu prime. Right? Okay, so how do I solve this?
Go back a month in the class.
Yeah. Yeah, or just solve the homogeneous one first, right? So you solve the homogeneous one first. I got z prime, well, zh prime, right? Plus 3 over x zh equals 0. Right? You gotta super keep track of what the heck you're doing, right? It's not that any of this gets really hard. It's just there gets to be lots of like sub steps. So now I'm in the sub step of solving the transformed things homogeneous equation. Right? So how do I solve this?
It's going to be e to the negative 3 natural log of x.
e to the negative integral of 3 over x dx, right? So that's going to be zh. So that zh is e to the negative log, negative 3 log of x. Right? And then, yeah, maybe, I don't know.
You move the negative 3 inside the natural log,
Yeah.
and then
Drag the negative 3 up, and then the log and the e cancel. So you get that your homogeneous version is x to the minus 3.
Uh-huh.
Okay? Okay? Then what?
Then you.
Well, back into our.
Variation of parameters.
Yeah, so remember this is z homogeneous,
Yeah.
right?
So we plug it back in.
Not z. So you need to use variation of parameters to solve this part.
So divide that guy by that guy.
So I think you guess z hat, right? Which is, I mean, some new variable, whatever. I guess I should just write that the easy way, right? No, I shouldn't. So I guess nu times x to the minus 3. And then I need to figure out z prime, z hat prime, right?
So far down the rabbit hole now.
Z hat was nu x to the minus 3.
We're going really deep in this one.
We're super, yeah, this is a super deep thing. Yeah, it's not actually hard, right? It's just really goddamn complicated. Like, there's just really a lot of steps. So, right now, I'm doing variation of parameters on that first order thing that I got after I found its homogeneous. Okay, so z hat prime, rather, is nu prime x to the minus 3 minus 3x to the minus 4 nu. And then what do you do with that?
Pop it into the z.
Shove that back into the original. So I got, well, the original equation is z. So I got nu prime x to the minus 3 minus 3x to the minus 4 nu plus 3 over x times nu over x cubed. And what's that supposed to equal?
Equals
4 over x.
4 over x to the 5th.
That's supposed to equal 4 over x to the 5th. And, oh, sick. That crap is a really fancy way to write 0. Cause
Yep.
why?
Variation of parameters.
Because variation of parameters works. Okay, so now I have nu prime times 1 over x cubed is 4 over x to the 5th. So multiply both sides by x cubed. That will get you to nu prime is 4 over x squared.
Integrate.
Integrate that. So
Negative,
slap a d-eater on this thing
negative 4 over x.
and get v is
Negative 2.
1 higher power over the 1 higher power, right?
Yeah.
So I think I got 4x to the minus 1 over minus 1.
Yeah.
Negative 4 over
Oh shit, y'all forgot it now. It's too deep. Too many steps.
plus c.
Plus cost. That's going to be the first of hopefully 2 constants, so I'm going to call that C1. Right? Why am I hoping there are 2 constants?
Because we had a second order.
Yeah, because somewhere here a while. Oh, good, I didn't even erase it. I started with a second order differential equation, right? So there shouldn't, like, even if I don't know anything else about what any damn thing is, I do know that there should be two constants, right? All right, so I found nu is this stuff, which may as well be rewritten as minus 4 over x plus c1. Okay, that's what nu is. Then you need to go backtracking, right?
Well,
So z hat,
anytime it's x to the minus third is mu prime. Is
Okay.
equal
sorry, let me see. Let's see, I don't need any of this stuff. I probably didn't need that. Oh, it's gone now. So my z, right, is the nu times the homogeneous version, right? So I think I figured out that z has to be negative 4 over x plus c1 times 1 over x cubed. Okay, so I got z is negative 4 over x to the fourth plus c1 over x cubed.
and then all of that is mu prime.
Okay, all of that is mu prime. You guys see why I didn't want to keep the mu prime all the way through that? Okay.
And take the integral and get back to mu.
Okay, so if I take that thing and hit it with a d-eater, right, that's going to get me mu is,
Oh, got
Minus 3.
So how about just C1?
integrating stuff.
C2, right?
Yeah, and really this doesn't need to be c1 over negative 2, right?
Because it's
That could really just be
C1.
c1. Like it's a slightly different constant, but who cares? It was an arbitrary constant anyway.
Yeah.
And then
Plus C2?
plus c2. Okay.
Multiply
And-
that by x, do that.
And then all that goes into what y was. So y should have been y hat, right? So y should be this thing times x. So I think a negative divided by a negative is a positive. So I got 4 over 3x cubed.
You need 4 over 3x. Squared?
I mean squared. Thank you. Plus c1 over x plus
C2x.
c2x.
So this gives us the particular solution too, right?
Yeah. Yeah, so if I was doing this the other way, right, if I'd actually done this to an equation that I could have solved the other way, I would have, here's, oh, I guess that's the second one, right? Because this is the first one. Right, I have my two homogeneous bits,
Oh yeah,
and then this is kind of playing the part of your y particular. You guys with me on that? That's not necessary, like, yeah, I'm labeling those, but maybe it would be more reasonable to just think those at it instead of labeling those. It's cool. Questions, Steele? Okay, cool.
That was fun.
They're super complicated, right? Like there's a lot of bits. But if you keep track, like keep a list of all the substitutions you've made, and then once you get to the end, you can just backtrack through them.
Yeah.
And there's only one technique, right, in the whole thing. You do variation of parameters, and then you notice something, and then you do variation of parameters again, right? But it just feels weird to
Yeah.
kind of float through this many variables. You guys got it.
You
For
just
real.
dig yourself into a hole and then like put yourself back out.
Yeah, it's a little bit like digging a hole and kind of like,
You
I
like
don't know,
find the
like
treasure.
putting the dirt in a backpack or something, right? And then like you get to the bottom and you like collect this thing and then you like fill the dirt in and stomp it down and fill it.
So it's like Minecraft?
Yeah, it's a lot like Minecraft.
Being a soil scientist.
Or being a soil scientist. No, those guys just leave their holes.
No, they have to carefully, they lay down a tarp, they dig the hole carefully, placing the dirt on the tarp. You know, and they've extracted their little sample, they replace the dirt from the tarp.
And there's our tarp of dirt on the
Yeah.
side.
Yeah, this is my dirt tarp. Exactly. Yeah, I like that. That'll work.